Let's add a BGP peering between the Kubernetes cluster nodes and the infrastructure nodes. There are two types of peerings that we will define. One is to P5 node, which is the Tor, and another one is to route reflector, which is shown, which is down at the bottom, where the PE devices also have the BGP peerings. So the peering on the infrastructure side is right now pre-configured. So if I go here to the route reflector, you see that we have 4 peerings up to every PE node, and we have 4 peerings down that each of them goes to Kubernetes cluster node. As of now, every Kubernetes cluster node needs to form a peering with route reflector. Once we have an embedded route reflector feature enabled in Cilium, part of the roadmap, then we will have a subset of Kubernetes nodes creating or forming peering with route reflector. So right now, the peerings are down. Exactly the same stands for a Tor device, which has neighborships pre-configured with cluster nodes, and they are also down. Keep in mind that the idea is that IPv6 address family, so essentially the locators as well as IPv6 CIDR that we care less in a bit in this use case will be advertised over this peering, and the VRFs will be advertised over the peering through a BGP route reflector. So let's create the peering and see what changes when we do that. We go to BGP. There is no peering policy defined right now. I hit plus button and I go with the defaults to avoid fat finger errors. But before I hit create, let's make sure we understand what we do. We create a BGP peering policy on kube cluster. We have a local ASN number, the same on every virtual router across all the nodes. We eventually want to export pools, locator pools, as long as they are having a labeled export colon true. So we make that configuration ready up front, and we form 2 peerings, one with the top of rack. It will be the eBGP peering to a connected local IP address. That's why the TTL is set to 1, and that will be for IPv6 address family only. Another peering is to the Tor, again eBGP, and I just picked up 255 as the default value. Peering is to the loopback IP address. Let's create. Create was successful. The kube API request has been sent to Kubernetes cluster. That's how I visualize the information that I just explained, what will be configured. Let me also go to a CRD Explorer and go here to BGP peering policy. That's what you would see if you would do a kubectl command. So pretty much all the information that I was exposing is there, as well as there is some information that has been hard-coded in a way on the API call. So for example, I set by export pod CIDR to true, map SRv6 VRF. It's also set to true. Also, some timers are pre-configured. So from the UI perspective, only the subset of information has been exposed. That's effectively the entire configuration that has been sent to kube cluster via the API. If we go to topology, I hope that by now peerings will be already up. So let's go to P5. Yes, they are up. So we have 4 peerings up to every kube cluster node. And we see that IPv6 address family is enabled and one network, one prefix is advertised. So what's that? Right now, it will be, I click on different one, it's a different network, right? What this network is, maybe you remember that from different recording, this will be the IPv6 CIDR for every node. So since pod CIDR was enabled in the BGP peering policy, as you've seen when I was showing the YAML file, these CIDRs are then advertised using the BGP over IPv6 address family. With regards to P6 route reflector, the peerings are up. That's what has been configured. But as expected, VPN v4 is not really sent by Kubernetes cluster yet, because it will need things like locator and VRF definitions that you will see.